Hi everyone, my name is Alex Bastavros. I'm a principal product manager with Amazon Web Services. I work in our EC2 Elastic Compute Cloud group on our infrastructure instance types. Today we're going to be talking about reducing cost with our next generation T4g and our current generation T3 instance types. So today we're going to go on a little bit of a journey. We're going to start by talking about the cost saving opportunity. Then we're going to go into an overview of our Amazon EC2 Burstable instance type families and why we designed the products the way they are. Then we're going to go into a little bit of a deeper dive into the specific offerings we have on our next generation T4g instances, which is our latest offering, and then our T3 and T3a instances. Then we're going to talk through some of the very specific target workloads that you should be thinking about using these instance types for. So let's jump in. I bet by now you're probably tired of AWS telling you how you can run your workloads more efficiently and save costs. This is typically a very big theme of what we talk about at reInvent. But I do want to get your attention. Today is a really big opportunity. So customers' EC2 instance costs end up dominating their bills. And it's really important that we innovate on behalf of our customers to build cost-effective compute options for many common workloads that we see you running in EC2. So first, I want to talk a little bit about some of the effective ways customers save money by running in EC2 and approach the cost savings. So first is the purchase model. When customers first start running in EC2 and they're exploring EC2, what we find them do is they actually use on-demand. On-demand is the most simple purchase option we have. It's essentially a pay-as-you-go option, similar to when you turn a light switch on at home and you turn on a light, the power company sends you power, you get metered, turn it off, you no longer get charged, right? That's the on-demand purchase model. What we've built is things like reserved instances, and our most latest offering are savings plans, which allow you to save up to 72% off the on-demand prices by committing to 1 year and 3-year terms. Savings plans should be used for all of your long-lived workloads because of the massive cost savings you can realize by leveraging these longer commitment type purchase models. Then we also offer the spot instances. Spot instances allow you to use unused EC2 capacity in the AWS cloud for up to 90% off the on-demand price. This is a really exciting opportunity, especially if you're very flexible. So this has been one of the very meaty ways we see customers save money and optimize their costs in EC2. The second way is our EC2 instance types. So EC2 offers the broadest and deepest portfolio of instance types, nearly 400 different choices for customers. The reason we built such a broad portfolio is because we build our instance types so customers can pick the right instance type for the workload that they run. Similar to how you pick the right programming language for the application that you're going to run. It's like the right tool for the job. And this becomes more and more important as customers innovate and run and bring more workloads onto the cloud. Another method is tools. So between our homegrown tools like AWS Compute Optimizer and several third-party tools, what we do is we actually can analyze your AWS resources and give you actionable recommendations to optimize. For example, the Compute Optimizer tool can look at what your instance trends are, how much activity they see, and can recommend a different instance size, or they can recommend a different instance type. So these are also very effective ways for customers to save cost. Today, what we're going to do is we're going to focus in on some very purpose-built instance types for your general purpose workloads that are optimized for low cost. So to illustrate the opportunity, let's look at an example CPU utilization graph. With many of our EC2 instances, like our popular M5, which is our general purpose, multi-purpose offering, and our C5, like our compute optimized offering, they're designed to work for your workloads regardless if you run 100% CPU utilization all the time, or if you run a much lighter workload. So this first graph I'm showing here is an example workload where a customer spun up an instance and runs it at max performance constantly. Perfect. You can run this with M5 and C5, and those are going to be great fits for the type of workload that this is representing. You actually might think your workloads are like this, but when we started working with customers and then even looking at our own workloads that we run inside the cloud, what we found was something a lot more like this. Right? This shows that there's still a lot of activity, but it's much more randomized. There's going to be times where things are processing in the background, or you're waiting on data to be sent to you, or you're waiting on network traffic to be admitted. Then you process it for some period of time, and then you're probably going back down to some lighter task. Think of this very much like how you use your PC or Mac at home. You click on something, open an application, that'll take a whole bunch of performance to set it all up. And then once you're there, you might be reading, or you might be thinking of the next thing you want to go do, or something a little more idle. And then you go compile or run some other application, and then it bursts again and then kind of comes back down. So this is what we call as bursty. That's how we got the name burstable instance types. So let's look at this more broadly. So that was a specific kind of workload where we were trying to illustrate the different types of kind of fixed performance where you'd see much more in HPC, and then the more bursty, which is a more common use case, right? So here we wanted to take a look more broadly and show that the average CPU utilization of instances really across a spectrum of low utilization and high utilization. So what we noticed was a pattern, right? On average, the CPUs on EC2 instance types are not very busy. We looked across a huge amount of instance type across our own workloads and working with customers, and this is very much a trend that we can replicate and see across several different workloads. What you see is that a massive amount, actually a large majority amount of instances are running very, very low utilization, close to idle, or very light workloads. And then there is going to be a set of workloads that fall along the spectrum and get to very high utilization that are very active. Think of like HPC and these simulations that customers run. AI and ML are going to be very, very busy, right? But you can see this massive concentration, and that's where a lot of these workloads fall. So to address these common workloads, we actually built cost-optimized product line in EC2 called the general purpose burstable instance types. And they're specifically designed to address those types of workloads, which is the large majority of what customers run. So let's get into some of those details. So first, these are the three characteristics that I associate and want to communicate to you to associate with the burstable instance types. The first is cost effective. When you think about the burstable instance types, these are going to be the lowest cost instances available to you in EC2. So on an absolute dollar perspective, or even price performance perspective, if you fall within how they're designed, these are going to be the most efficient way to run your general purpose workloads in EC2. So think low cost, burstable should be the first thing on your mind to go think and evaluate. Second thing is, the way we designed them was we offer a generous baseline performance. So baseline performance is effectively a way we denote the average CPU utilization of the instance. So we provided an average CPU utilization included with the instance type to map to that broad spectrum of workloads I showed on the previous slide. And then having the ability to burst beyond that to as much performance as you need, which makes the instances a lot more flexible for different types of workloads that you might run with them. The third characteristic is you're able to burst whenever you want and for as long as you want. It's not practical that everyone watching this or everyone who looks at our burstable instance types really knows exactly how their instance is going to run, how their workload is going to run. Things change all the time. Some things go viral. Maybe you have a new service that launches and cannibalizes your old one. So it's hard to tell sometimes. So we also built in the capability for you to be able to run the instances at full performance for as long as you need. However, when you start getting to that point, then you need to start reevaluating. Like, does this really fall under the moderate to low CPU utilization use cases? And should you be moving to a non-burstable instance type? But the key thing is that you have that flexibility, and you can always start here and then always move and adjust as your workload becomes more predictable. So given all the attractive cost benefits, the most common question I get is, when should I use the burstable instance types? For what workload? So one of the challenges in answering that question is that we built these to apply to a broad set of common workloads that run in the cloud today. So while I'm going to get to more specifics closer to the end of presentation, The way I want to frame this discussion right now, instead of rambling off just a list of workloads, is talk through some of the characteristics of the workloads that we've seen run successfully on the burstable instance types. So first off, general purpose workloads, general purpose referring to things like your web servers, your dev and test, your code repositories, anything that you kind of just you need to go do, you need to go run it, microservices, for example, all of those that don't really need a lot of fixed CPU resources, right? There's many things in the cloud just really aren't CPU intensive. So all of those kind of fall into that first bucket. The second bucket is applications that occasionally need access to high CPU. So I like to think about this in like a Internet of Things or data logging environment where periodically you're going to get a whole bunch of data, you need to process it, maybe transform it, and then write it somewhere, and then you're probably going back to a more idle or lighter workload or task. Then the third category falls in this kind of idle or moderate CPU needs for the majority of time. I think the easiest way to think about this is back to the your PC or Mac use case, where you find yourself, your computer probably sits idle for the majority of the time, and then every once in a while you open an application or open a web page or run a video, for example. And those are the ones where you're sitting idle the majority of the time, and then you have times of high need. And then the third one is to think about that you have the ability to burst for as long as you need. So if you're not sure, and like I talked about on the previous slide, if you're not sure how your workload's going to work and you need to burst, once again, we provide that flexibility here. So that is something that can be done, but that's when you probably need to make more of a trade-off and do a deeper dive and figure out, is burstable right for me, or should I be looking at a non-burstable instance type? So let's bring that all back together. So one, burstable instance types, they are the lowest cost. So let's put some numbers behind that. M5, a very popular instance type for our customers to run in EC2. Using burstable instance types, specifically with our latest generation T4g instances, you can actually save up to 30% off the M5 cost. That's a significant amount of savings for your infrastructure, literally by just changing your instance type. These are designed for general purpose workloads. So we didn't purpose design these to go after some of these very specific use cases that you've been bringing to us as customers, but a lot of general purpose workloads, including things like running lighter databases, for example. We talked about web servers. We talked about running remote desktops. Those are all fall into this kind of general purpose category where they're typically idle, and then there's times where they need to burst where they have high demand. That's another great way to characterize of when these should be used. And then another thing is instance size options. A lot of customers come to us and talk about the different sizes that they want to run on the instance types. For example, our M5 instance that we talked about here in the first example for cost savings, the lowest size that we offer there is going to be a large size. This is where you get 2 vCPUs and 8 gigs of memory. On our T3 instances, for example, which is a burstable instance type, we have that same size, so 2 vCPUs and 8 gigs of memory. What's really cool about the burstable instance type is that you have the ability to actually select smaller sizes. We actually go all the way down to what we defined as called a nano. A nano is 2 vCPUs and half a gig of memory. That's a really exciting, because not only can you save money on using the exact same amount of resources with 2 vCPUs and 8 gigs using the large as an example, but you can also scale it down to much smaller instance sizes, making that a really nice way to pick small sizes and kind of smaller pieces of this really powerful large hardware to run some of your lighter workloads at a much more effective cost point. So let's talk a little bit about some of those characteristics when I talked about baseline and bursting. So I think the easiest way to talk about this in the time that we have here today is to illustrate it. So here's that workload. This is the one that I called as bursty. And what we did here is on top of it, I mapped out, here's what the average CPU utilization of this workload is for some period of time. Let's call this 24 hours. Maybe this is a business critical application, and early in the morning you have one big spike, and then after lunch you have another big spike, and then it's largely idle, and then early morning you start spiking again as people start accessing a certain database, for example. So let's call that a 25% CPU utilization. If you run that on a T3 large, that has a baseline of 30%. Now what baseline means is it maps very, very well to the average CPU utilization. This means that you, on average, are running at 30% of the CPU resources or lower. That's called the baseline zone. This means you're actually leveraging the T3 in the right way, you're getting great cost savings, and we're working within the specification of how the product was designed. That's the baseline zone. What customers get confused is they feel like, oh, I have to stay below 30% utilization. That's not the case at all. The burst zone is absolutely, like as you can see with these spikes, they're running in the burst zone. That is absolutely part of how the product was designed. When we talk about bursting above the baseline, what that means is that the green line or the dotted line starts creeping above the green line. That's when you're using the product more than what it was specified with 30% baseline. And that means you're gonna have to start paying for additional credits. And that's when you should start thinking like, okay, should I be using the burstable instance type when your CPU utilization is over 30%? Or should you be using a non-burstable? Because typically when you get in that 30–40% range, you probably have a much heavier CPU utilization workload. It doesn't really map to that kind of fat part of the graph that I showed with the broad spectrum of instances. So that's kind of the introduction. Let's talk a little bit about the family and where we've been and kind of where we're going. Our CEO, Andy Jassy, always says there's no compression algorithm for experience. You know, our first EC2 burstable instance type was launched back in 2010. And our roadmap has accelerated recently with a new major instance offering every single year. So let's talk a little bit about how this roadmap where we've come from. So starting back in 2010 with our T1.micro, we saw a huge opportunity for the exact same use case that I talked about in this slide. And then we saw, well, customers really want to do more with this, right? So you bring in T2. This offered more sizes. So the micro size kind of being that small, really small size, but offering small, medium, and large. Some very popular sizes brought a lot more capability to the product. So more vCPUs, more baseline performance, and more memory, right? Making them more powerful so you can actually run those workloads when you are going to be needing those CPU resources. Then in 2015, we launched Nano. This is where we saw, okay, people even want smaller sizes, smaller denominations, even half a gig of memory for very, very, very light workloads that you can run very cost effectively. And then on the top end, you can see here in 2016, launching extra large and 2x large. So offering more vCPUs. So beyond the 2 vCPUs a large offers, you can get 4 vCPUs and 8 vCPUs with a extra large and 2x large. And then in 2017 came a really pivotal point for the burstable instance family. What we did was we launched something called unlimited mode. When we talked about baseline, before unlimited mode, the baseline performance was the most CPU you were able to get out of the product. Now that caused a lot of concern with customers because they weren't sure, like, am I going to be at that baseline? Am I going to be below it? What happens if I go over it? And it got, almost like tricky where customers weren't able to trust the product. So unlimited mode effectively unlocked it. We said, look, you can run beyond that. And this was not intended to be something that you did constantly, but it was more about like you have an insurance policy, right? If you're running on a T instance, like I love talking about this running a web server where you're doing like e-commerce and say you had a sale that went viral, you wouldn't want to lose sales because you're trying to, cost effectively run your infrastructure. So unlimited mode gave you that ability to run as much as you needed for those kind of unplanned times. And that once again unlocked the product, made this a lot more useful for customers. So in 2018, we launched our T3 instance types. So this starts kind of the theme of where we talk about our roadmap in kind of 3 major areas. So the first one is lower prices. So T3 was launched. It was at a 10% lower cost than T2, so focused on bringing more price value and lower prices to customers, but also increasing on the performance end, up to 30% higher price performance than what you see on T2. Continuing that theme of cost, we launched T3a. So we brought in our AMD processors, got a lot more efficiency out of the CPUs, and we're able to enable another 10% cost savings. Similar with our latest generation T4g instances, these launched at a 20% lower price than T3. So continuously bringing that lower price point to customers. Then new features, right? We talked about unlimited mode. Then in 2020, earlier this year, we launched something called dedicated instances. This allows you to run T3, the cost-effective T3 instances in a dedicated environment where you're able to just run amongst your own AWS account. So this was great for bring your own license types of workloads where you have maybe a restriction on the licenses and how you can run it in the cloud. And then for compliance, where you have to operate a certain way to meet a certain compliance. And then, of course, we have much more coming soon, following on this trend of prices, flexibility, and then features. And that's how we're thinking about this roadmap going forward. So let's get into some of the specifics. So today we have three major pillars of our burstable instance type offering. So first, I want to focus on our Intel-based T3 instances. So we leverage the latest generation Intel Cascade Lake and Skylake CPUs to run our T3 instance types. These will offer you the best price performance for all your x86 workloads and are really a standard offering across several of our AWS services and customers. Then a year later, we brought in AMD. So AMD enabled us to offer a new level of economics in our own data centers, and then we've been able to pass that on to customers at a 10% lower price. So those become almost the most cost-effective way to run your x86 workloads, which is on that theme of lower prices. And then most recently here in September, we launched T4g instances. And these have really changed. This is kind of like a once-in-a-lifetime launch, not just for Burstable, but across our EC2 portfolio, where we're able to offer a massive step up in performance of 40%, and then a huge step in cost at 20% lower cost. So really providing that significant value jump that we don't see that often on a generational upgrade. This is really like a once-in-a-lifetime type of upgrade. So let's start with T4g. This is our latest offering. I think it's a great place to start. So first, these feature our latest AWS Graviton 2 built CPUs. These are based on ARM Neoverse N1 cores, and this is our second generation CPU. We first launched Graviton at reInvent 2018, and then since then we've iterated and really came up with a super high performance, very cost-effective way to run infrastructure, and that's what Graviton 2 is based on. So compared to T3, these give you up to 40% better price performance and 20% lower cost. That's a significant amount of performance benefit when your workloads are active and they really need that performance. And then when you think about cost savings, which is really what I was trying to tell you earlier about putting in your head as the first way to think about the burstable instance type, 20% lower price. This almost becomes like a no-brainer type of offering to evaluate. It is on ARM, and there's an ecosystem that we've built around that. So that's a consideration depending on what type of workload you're running. But we've seen a lot of traction on this one. And we're so confident that customers are going to love this that we've set up a free trial. So you can actually try T4g.microsize for free up to 750 hours per month until March 31st, 2021. So all payer accounts in AWS get access to these 750 hours, which allows you to essentially run it nonstop for the full month, which is really exciting. So as a real nice call to action, and I want you to see all the work that we've put into this next generation. I really challenge you to go try this out. It doesn't cost you anything, and I think you'll really be impressed with the type of product that this is at the cost point that we offer it at. So some of the key features, let's go back to T4g. So one, cost effective. So we've enabled this with our own homegrown AWS Graviton 2 processors. These are the lowest cost instances in Amazon EC2, bar none, and the highest performance. So what does that mean? That means you get the best costs when you're trying to reduce your costs or you're trying to think about building a new app. These are super cost effective. Right, we covered the opportunity. We know this will work for majority of your general purpose workloads. And then when you do need that performance, that's when Graviton 2 really shines. And we can really show you that this can burst and show you some really, really amazing type of performance profile, up to 40% higher than comparable x86 instances that we run in our data centers today. Flexible, right? Across the Graviton 2 family, which we've launched now in our compute optimized C6G, our general purpose M6G, and then our memory optimized R6G. What we've done with the T4G is being able to offer you that flexibility. So if you want to get down to those smaller instance sizes, get those smaller denominations, now you have that flexibility all the way down to half a gig with two really powerful Graviton 2 cores. So this becomes a super exciting offering for all different types of work. I actually think this is going to unlock a whole bunch of new workloads to be enabled in the cloud. So performance, we've talked about this, up to 40% higher. Why does that matter for T? Right? T is not just for cost. You still need that performance when you're bursting, right? It's just that you're not bursting all the time. So providing more performance in those times, make sure that your applications are still very performant and you're still really meeting the needs of the requirements that you have. And then being able to leverage that ecosystem, right? Across Graviton 2, we brought in all the different popular Linux operating systems, including Amazon Linux 2, Red Hat, SUSE, Ubuntu, and then several applications in AWS. It's supported across several of our ecosystem and then our third parties. To name a few across the container space, like our ECS offering, EKS, ECR, and then AWS CoBuild, just to name a few. But there's much more that I couldn't even fit on this slide. So next, let's talk about our current generation T3 and T3a offerings. So these are very popular today because several of the workloads haven't really got a chance to adopt that Graviton 2 benefit yet, and people are running legacy workloads. So when you're looking to optimize things that you're already running in the cloud or running in on-prem, these become a fantastic offering, right? These are all x86 based. They're based on the latest CPUs from Intel and some cost-effective CPUs from AMD, providing you really nice flexibility. The T3 instances, as we talked about earlier, those are going to be 10% lower cost than what we offer on T2 and up to 30% higher price performance. And the T3As are really enabled to drive down really for economics, right? So another 10% discount on top of T3. So providing a very cost-effective way for you to run your x86 workloads. So a lot of flexibility here, right? You got Intel on the price performance side, and then you have T3A for even better costs and economics. And so while T3 and T3A have been very popular with our customers to optimize costs, we also use them in AWS to enable all different types of cost-optimized services for our customers. For example, RDS uses T3 for several of their lower cost options across several of their database engines. Just to name a few, a very popular Amazon Aurora has T3 as an option, or PostgreSQL as an option, and many, many more engines. So you can see how we've even been able to leverage these internally with our services. Another example, SageMaker. You can use T3 for running your AI and ML notebooks and some of your processing. It's another really cost-effective way to do that. Not everything requires the most performance all the time. Like, these become a great way to run several of the common workloads we see. Recently, we launched T3 as part of our Amazon MSK, or Managed Streaming for Apache Kafka. T3A gives you really low-cost options for your broker nodes. Another really great use case for how to think about when T3 becomes a strong option for your service. So we do this internally, and we've seen our customers do it, but just want to share, as you think about what the burstable instance types can do, they can really unlock a new level of workloads or a new customer base for you as you think about some of the economic benefits you get by running T. So as I promised, I gave you kind of the framing of how to think about the workloads, but I do want to name through a few so that way it can help trigger kind of that next step and make this more actionable as you go back to your businesses and try to see where maybe the burstable instances might fit for your workloads. So here's some of the places that we've seen a lot of success with T3, with our customers, T3 and T3A and T4g. So first is microservices. Like I said, you get to choose really small sizes. So if you build your own, you can have your big scale out up to the really small denominations, depending on how heavy each service is. Web servers, a great use case for a lot of different customers where they don't have a lot of super active servers. That could be a great one too. Small and medium databases. We use this across our managed database offerings like RDS and Aurora. However, think about your own databases. Could this be something where you don't see high demand all the time for database accesses? It could be a really great option for you. Data logging, we talked a little bit about that. Code repositories. Virtual desktops, another very popular use case. I've already talked about it a few times, but think about how you use your Mac and Windows PC. It kind of really fits the profile, and you get access to really powerful servers when running that. That's exactly what the burstable instance types were designed to bring. Development and test environments has been a kind of a stronghold of where burstable instances get used, just because they're very cost effective to run large scale development and test environments. And then all your business critical applications that you run in-house, another great use case for them. So many, many, many more. I don't want to limit you to this list. We use general purpose as this wide net, but these are some of the top ones that we've seen a lot of success with Burstable instances. So hopefully that helps you think through a little bit of where these can be used. So let's recap. So the Burstable T4g, T3, and T3a instances offer the lowest cost points in EC2 to run your infrastructure, bar none. They're optimized for a broad set of workloads, and then we offer flexibility across our latest generation Amazon developed Graviton2 processors, which are the highest performing processors we develop. We offer the latest generation Intel processors with Intel Cascade Lake, and then very cost-effective AMD processors as well. These are available to purchase across all of our different models. So we talked about on-demand kind of being the basic one, an easy way to spin up instances, but you could also leverage savings plans and Spot on top of Burstable to get the maximum amount of savings. And get started for free today. If I was to leave you with one message from this presentation, it would be go try it. We're giving away free usage on T4g until March 31st, 2021. I would love for you to go try it, send us some feedback. It would be a really exciting, I think it's a really exciting product given both the performance and the cost benefits that the Graviton2 processor was able to enable, but integrating that into our Burstable family has been a really exciting opportunity. We've gotten a lot of really strong feedback from customers on that one. So thank you so much for joining with me. I know we didn't have a ton of time to go through all the little nitty-gritty details. We have tons of documentation on our Burstable instance types on our website and in our docs. So please feel free to browse. If you're interested with more information, please reach out to your Amazon salespeople or contact us directly. I'd love to talk with you. So thanks so much for joining me today. I know all your time is super valuable. So to help us make sure we're offering the best content, please complete the survey. I would love to hear feedback on how you enjoyed our session today. Thank you so much.